No way. What? Hold on. That's not. Carry the 3. My math is right. There's no way. I need to tell someone about this. Hey world! Electric vehicles are still cleaner than gas-powered vehicles, even if that electricity is coming from a gas power plant. From a gas power plant. From a gas power plant. I guess I'll try YouTube. Hi everyone, hi. Isn't Michaela here? Probably know that. My mind is blown right now, and are you ready for yours to have the same blownness? Are you ready to have your mind blown as well? Blown? Your mind blown. That's the goal here, and that's what's happening, okay? I have been doing climate advocacy for the past 2 years, okay? I'm an ambassador for the World Bank. I'm writing a position paper on transportation emission reductions for the World Bank, and yet it took me until just now to actually crunch the numbers on this problem for my research, and I'm so happy that I did because I learned some things. So in this video, I'm going to talk about electric cars and gasoline cars, talk about what some of the common logical fallacies are, e.g. double standards, used to assert that gasoline-powered cars are better, and hopefully by the end of this video, you'll have a renewed appreciation for electric cars and maybe want to get one yourself. The old myth, or the argument that honestly I had believed until very, very recently, was that if you're running an electric car on anything that's not renewable energy, it's just as dirty, if not dirtier, than a gasoline-powered car, so there's not really a point. And I believe that. That made sense to me, but there's a lot of parts of this problem that are not being talked about. The first logical fallacy is the double standard. Basically, you're judging two different things on two different criteria. When trying to make this argument for electric versus gasoline cars, you're effectively saying that we're going to consider the entire emissions profile of all the energy needed for an electric car, but we're only going to look at the gasoline in the combustion car. When in actuality, there's way more energy that goes into that combustion car because that gasoline has to come from somewhere. It needs to be drilled, it needs to be transported, and then burned into the combustion-powered car. All of that is not a thing for electric vehicles. So you need to account for all of that when you're thinking about a gasoline-powered car. I saw a YouTube video that had a really great explanation. I'm going to link it in the description below, but I'm going to take a slightly different approach and simply do a raw, simple calculation. Please watch for the numbers on your screen appearing from your left, right, above, center, or below. I'm not sure where it's going to be yet. I didn't do the editing. But the math is actually very, very simple, and I'm going to take you through how we calculated it. So to calculate this problem, we need to calculate the emissions per mile for both the standard electric car and the standard combustion-powered car. Make sense? The electric-powered car is actually really easy to calculate. All we need to do is take the electricity required to go 1 mile for your electric car, multiply that by how much emissions a power plant creates per kilowatt, and then that's your answer. If you multiply those two things together, you get the kilograms of CO2 that are emitted per mile of driving an electric car, as long as it gets all of its energy from that power plant. And it turns out those numbers are really easy to calculate. The standard electric cars, in my research, on average, take about 30 kilowatts per 100 miles of driving. That amounts to 0.3 kilowatt hours per mile. The emissions of a typical power plant, as taken from the EPA, approximately range between 0.82 and 1 kilogram of CO2 per kilowatt hour. So I just used the average in the middle, 0.92 kilograms per kilowatt hour. Multiply those things together, you get 0.267 kilograms of CO2 emitted per mile. However, it's important to understand that these results only apply to natural gas power plants. Coal-fired power plants are insanely dirty, about 6 times dirtier than a natural gas power plant. If you try to run an electric car off of fuel from a coal-fired power plant, the results would not be cleaner than a gasoline-powered car. But the good news is that because natural gas and renewable sources are becoming so much cheaper than coal, the market will naturally drift away from coal. So we can expect that every year, more and more plants are going to be either natural gas or renewable, and we won't have to worry about using coal for our energy sources anymore, which is great, but just take the rest of this analysis into account that we are going off of natural gas power plants only for now. So remember that number, log that away. Now we're going to talk about the gas. So a gasoline powered car has three basic sections. There's making the gasoline, there is transporting the gasoline, and then there's burning the gasoline. We need to take all of that into account to get our final number. Let's start with producing the gasoline. In the United States, they typically manufacture 19.2 million barrels per day. That is a huge number. I'm just gonna put it on the screen. Okay, that's a big number, which equates to a lot of barrels per year, which then equates to a lot of gallons of gas per year. Okay, so we have the gallons of gas per year that the oil industry produces. Now we take how much CO2 is produced per year for these refineries, total for the United States. That number comes out to be 1.77 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 metric tons of CO2. It's very, very fun. We have how many gallons the country makes. We have how much emissions the country produces in their oil and gas refinery sector. We just divide the two, and we have the metric tons of CO2 per gallon of gas. Then we just have to convert metric tons to kilograms, and then multiply that finally by the mileage of your car.
By multiply, she means divide. Common mistake.
So typically I just had an average of 25 miles per gallon, and that would give us 0.053 kilograms of CO2 emitted per mile. So current scoreboard is 0.26 kilograms of CO2 and 0.053 kilograms of CO2 for combustion. So far, the combustion-powered vehicle is winning, but we're not done yet. Now we have to talk about transporting the oil. Oil transportation takes a lot of energy, and these ships and oil tankers are very, very, very dirty things. And I just don't mean physically. They emit a lot of CO2. I actually was able to find a research paper that cataloged the emissions profile for transporting oil to the United States. Taking those numbers, it turns out that they estimate about 0.027 kilograms of CO2 per liter of crude oil. If you consider that there are about 159 liters in a barrel of crude, and then assume that you make 19 gallons of gas per barrel of crude, you end up getting 0.22 kilograms of CO2 per gallon of gas. And then you have to just divide that by the miles driven, and then you end up getting 0.009 kilograms of CO2 per mile for your car. And the process of making the oil, drilling it, and transporting it gives you approximately 0.062 kilograms of CO2 emitted per mile for your car. So far, as it stands, electric vehicles are still worse, but we're missing the last and most crucial part of this equation, and that is actually burning the fuel in your car. According to the EPA, a typical gallon of gasoline releases 8,870 grams of CO2, which is 8.87 kilograms of CO2. If you divide that by the mileage of a typical car, which we're assuming is 25 miles per gallon, you end up getting 0.355 kilograms of CO2 emitted per mile. So every mile you drive with a combustion vehicle, you are effectively emitting 0.41 kilograms of carbon dioxide, which is almost twice the amount emitted by an electric vehicle that's getting its fuel from a power plant. And the best part is that this equation is completely independent of how much carbon dioxide it takes to make an electric versus a conventional car. That's actually another big point of contention. There's a lot of people that are like, well, it takes a lot of carbon dioxide to make them their electric vehicles. It's a lot. It's a lot, and it's probably more than the combustion engine, so we should just keep driving those. But no, because this equation calculates per mile, which means that the difference between conventional and electric emissions will grow every mile that you drive. And eventually, if you drive enough, you will overtake the set difference in CO2 it takes to produce an electric vehicle. I hope this made sense, because this is a complete mind blow to me. I am so happy I ran the numbers on this. It's completely wired the way that I think about like electric vehicles and the way that I think about advocating for climate change and helping the planet. It's okay if you have an electric car, but it's not from 100% renewable sources yet. Just get one and plug it in. You can also get involved by making sure you contact your politicians and your local representatives and making sure that they are providing adequate power banks at gasoline stations and as well as in your households, in apartment complexes as well, so that you can actually get a charge on your electric vehicle. We need to put the infrastructure in as much as we can and support this market as much as we can, because the market is expecting to grow a huge amount in the coming decades for electric vehicles. So that's my discovery. That was my discovery today. I hope that you're having a great day. I hope that this blew your mind a little bit. I'll probably be back with more climate videos and or build videos, depending on when I can get this project done. And if you can afford it, make sure you get that electric vehicle next time it's time to, re-up on your car. Lastly, but not least, like, comment, subscribe on this video if you learned something new. Definitely share it. It's a great way to rebuke some of the climate change arguments for electric vehicles that you see on the internets. And we definitely need more of that. So definitely fight the good fight. And I will talk to you all later. Thank you for watching, and see ya.